So I'm looking at question 9 in chapter 3 on page 47 out of the ThinkDO textbook. And it's asking us to identify the shapes of the distributions and then thinking about which is the most variation, smallest, well, in this case, standard deviations. I'll talk about them all here. So I guess I'm kind of taking this off the shelf as far as people being able to earn points for posting about it. So let me come to something I can write on here and we'll do some looking at it. See what I do. I screen captured it here. Here we go. Maximize this. I'm going to get rid of me here. So I see one peak in the middle. I see a fairly symmetric distribution, and so it's kind of a bell shape. So this is a bell-shaped distribution. It's actually unimodal because there's only one mode, one class occurs most often, and symmetric. So that's the fancy name of talking about something that's bell-shaped. Okay. Now, is it normal? I don't know. It's probably, but there's a lot of other metrics that it has to meet to be a normal distribution. How the heck do you spell symmetric? Symmetric, close enough. Okay, this is more or less a uniform distribution because more or less they're all the same. So like rolling die, or in this case it would be rolling die because there's more than 6 outcomes. And this is a nice symmetric distribution, but it's not unimodal. Okay, so neither of these are skewed. None of these are skewed. So this is symmetric, but it's bimodal. These two modes. So I got them named. So which would have the largest standard deviation? Which would have the smallest standard deviation? Well, the easiest question to answer is this one. When you have a distribution that's a bell shape, unimodal symmetric, that's going to have the smallest standard deviation. That's why we use the mean and standard deviation to talk about them. So bell shaped. So that's going to have the smallest shaped. This is going to have the smallest. Um, I don't know if I should use the population standard deviation, the smallest standard deviation, and because that'll have the smallest variance also, right? Then we're going to come down to between these two. Now, just because I know that the standard deviation is the average distance from the center, you see how these are all kind of, I would say this was we have the well, maybe let's go look at this one. See how these are piled up? These are piled up way far from the center. So this will have the largest standard deviation, the largest variance. Okay, because it's thinking about the averages in the center, they're piled up. But this one is kind of uniformly spread, so that's going to be somewhere in the middle. So that answers that. Okay. So I think this answers your question about how can you tell which has the most variation? Now, if it comes to a skewed distribution, now they didn't throw one of these at us, but whether it's left skewed or right skewed, these usually have even a larger standard deviation variance, right? So that, remember, this is a right skewed tail to the right, and it's skewed, not screwed. Sometimes people get that confused. Um, and left skeweds look something like this. Right? Tail to the left. So those, I mean, they didn't ask us that here. If I had to talk about which, this is going to have a fairly large standard deviation because it's a skewed distribution. This is why let me get a pointer going here. Come on. This is why with a skewed distribution, we use the median and the IQR, or the median and the 5-number summary, to talk about center and spread. Okay, we won't use the standard deviation here because it's going to be so big. You often the median, the mean is the standard deviation is larger than the mean, depending on the data set. Uniform distributions are just kind of weird. We aren't going to really spend much time with them. Maybe in terms of probability, we will. And this is just a so what kind of cool look. If we saw often when you have bimodal, maybe Dr. Stevens has talked about this. I haven't watched his videos in a while. If I see a bimodal distribution like this, I might think it's two different populations, and I might be better off working with the two different populations separately. Okay. Um, yeah, I guess that's it. I hope this answers your question, and ask some more if it doesn't. Let's see. So I'm gonna can stop my share, stop my program.